In this video, we're going to learn about a very important classification technique called logistic regression. Logistic regression is often one of the first classification techniques that people learn about. And it's important to note that even though the name regression is in the name logistic regression, it is not a regression method. It is a classification method. The reason that regression is in the name is because we are technically predicting a continuous value between 0 and 1 in the case of binary logistic regression. And that value between 0 and 1 represents a probability. And so if the probability is closer to 1, then we're going to predict whatever the 1 outcome is associated with. And if the probability is closer to 0, then we're going to predict whatever 0 is associated with. So, and it's called logistic regression because the output distribution tends to follow this logistic curve, which has this S shape to it, and it goes from 0 to 1. So we might output something close to 1 or close to 0. And that's how we make a binary classification of categories. So let's go a little bit into the math. The first thing about the math that we need to understand, and the page that I'm scrolling through in this video is our blogs on MLPro in particular for today. It's the blog post on logistic regression. So the main equation in logistic regression is the sigmoid function. And it looks like this: 1 over 1 plus e to the negative x. X you could think of as your as the output of a linear equation. We'll talk about that in a little bit. But whatever the value of x is, when we apply the sigmoid activation function to it, it's going to convert that number x, whatever x happens to be some number between 0 and 1. Okay, so let's start there. The next part of this is that, we could take the sigmoid activation of anything. So the sigmoid activation of x is over 1 plus e to the negative x. So with that background, and given your knowledge of linear regression from our regression tutorial series, let's understand what logistic regression is. Here it is, so pay attention. Logistic regression is simply the sigmoid activation function applied to the mx plus b equation from linear regression, where the m and the b are the parameters. In logistic regression, m and the b are also the parameters, the things that the model is learning, except we don't take the sigmoid activation function of x, we take the sigmoid activation function of mx plus b. So mathematically, sigmoid activation of mx plus b is f of mx plus b, as we saw above, which is 1 over 1 plus e to the negative mx plus b, which that is mx plus b here, should be in parentheses all. So that is our sigmoid activation function, and we can do gradient descent just as we would before learning m and b's and updating the value of m and b, as we saw in our gradient descent video, but doing that same process now for this equation instead of just for mx plus b, for 1 over 1 plus e to the negative mx plus b. But this 1 over 1 plus e to the negative blah blah blah, all that is constant, and it's really the m and the b that are the parameters, with x being the input value, just like with linear regression. So this is really not too far of a stretch from linear regression. If you understand linear regression, which if you haven't watched A, our linear regression tutorial video, and B, our gradient descent video, then you should definitely watch those, because those are prerequisites to this video, I should have said. So if you understand those, then this is really just a simple extension to that, but instead of predicting a continuous value, we're predicting a probability, where that sigmoid activation is giving us that probability. So the other difference between linear regression, besides the parameters that we're trying to learn, is the loss function, or the function that we're trying to optimize to minimize the loss. We remember, so in linear regression, it was mean squared error. We wanted to minimize the difference between the true value and what's predicted and that squared. So we wanted to minimize that difference. That doesn't quite work for classification. So in classification, what we do is something called cross entropy, which in the case of binary classification, we use a binary cross entropy loss function, which looks like this, or you can think of it like this, where y hat is the predicted value and y true is the true value. So this is nice because it gives us a continuous function, which is required for doing calculus on. In other words, for taking the gradients in gradient descent, you're going to need a continuous function. And cross entropy gives us that continuous differentiable function, which is very convenient for doing calculus. And so the final loss function is just to sum up for all our data points the cross entropy loss and minimize the sum of the cross entropy loss for all data points that we're predicting. Okay, and then if you again review the gradient descent video and blog, but essentially the same process is there, except we're working with the partial derivative with respect to m of the binary cross entropy loss and the partial derivative with respect to b of the binary cross entropy loss, where the predicted value is simply this 1 over 1 plus e to the negative mx plus b from before. So we won't walk through the math here because we walked through that extensively in the gradient descent video, but essentially same process, just switch out the equations. Again, we update the m and the b values using the exact same process as before. And then finally, once we've learned our m and our b values, then we have a logistic regression binary predictor where the m and the b parameters have been learned. You input x and you make a prediction. And if you have multiple inputs, then this starts to look like m1 x1 plus m2 x2 plus m3 x3 plus ... plus b. So just more m parameters when you have multiple inputs. And then we have a classifier that'll output something between 0 and 1. So that's how logistic regression works. I recommend that you work on the MLPro coding problems below to really reinforce these concepts, and also read our blog posts of this page that you're seeing now on mlpro.io/blog/learn/logistic-regression to really reinforce the concept. So thanks for watching, and you're one step closer to being an MLPro. You now know the details of one of the primary classification methods. See ya in the next video.